Assalamualaikum. My name is Muhammad Rizman and I'm gonna present to you my research paper titled Performance Analysis of Artificial Neural Network Approach on Solar Radio Burst Detection. This figure shows the approximation of size of the Earth as compared with the Sun. Sun is defined as the center and energy source of our entire solar system. This is why observation on the activities of the Sun is important, as it will affect the normal condition of our Earth. Thanks to the advancement of science and technologies, now we can observe the solar energy using various equipment and tools. Solar radio burst defined as a massive solar radio emission related to the solar flare event. Solar radio burst is an early sign of the solar flare before it reaches Earth. Compact astronomical low-cost, low-frequency instrument for spectroscopy and transportable observation (CALISTO) used to monitor solar radio signal, which measured in solar radiation flux unit. This paper will focusing on solar radiation parameter and use it to develop prediction model for solar radio burst using artificial neural network approach. Solar flare event affected and condemned telecommunications network, satellite system, navigation system, international grid system, and others. Solar radio burst defined as a disruption in radio frequency spectrum and appear in a low frequency signal, and it is an early sign of solar flare event. Solar radiation is defined as amount of solar energy which successfully penetrates Earth's atmosphere and absorbed by the surface of the Earth. In order to observe the solar radio burst, solar radiation data is needed. CALISTO receiver instrumentation able to detect solar radio burst between the range of 45 to 870 MHz. It uses variety of antenna to capture the burst. As for Malaysia, log periodic type antenna is used and its coverage is shown in figure below. Artificial neural network defined as a decision-making process using mathematical function to solve various problems inspired by human brain analogy. It consists of numerous neurons which is in interconnected order and placed in the group called input layer, hidden layer, and output layer. There are two major types of artificial neural network, which is static neural network and dynamic neural network. Static neural network flow in one direction only and does not have any feedback. Dynamic neural network is more complex with feedback mechanism and flow in more than one direction. This figure shows an example of static neural network architecture. Dynamic neural network has a memory and can be trained to learn sequential or time-varying patterns. In dynamic neural network, the output depends on various parameters, such as current input, previous inputs, previous outputs, and states of the network. Nonlinear neural network autoregressive model with exogenous input (NNARX) is one of the dynamic neural network. There are two types of NNARX, which is parallel and series parallel architecture. Parallel architecture defined as a closed-loop architecture. The output from the network is feedback to the feed-forward network as an input. The prediction is performed with the combination of present and previous input and feedback from the past predicted values in form of time series. Series parallel architecture defined as an open-loop architecture. The true output is created during the training without the need of feedback to estimate the true output. The prediction is performed by the combination of present and past value with additional trained past value. This paper focusing on developing prediction model based on static neural network and dynamic neural network using NNARX approach with parallel architecture. The data used in this research is retrieved from CALISTO. Prediction is made based on solar radiation value since the parameter obtained from the CALISTO is in solar radiation flux unit. Performance analysis is carried out for both results to see which one is given less prediction error as compared with the actual solar radiation values. Note that the solar radio burst event is shown with the highest reading obtained as shown in the graph below. The data shown in the graph is the weekly average value of solar radiation captured by the Callisto at Malaysian Space Agency at Banting. This paper performs static neural network and NNARS to predict the value of solar radiation using several input parameters such as previous output data and temperature value at the time. To perform a prediction, the maximum solar radiation must be normalized to 1. The analysis is carried out using several parameters, which is mean square error, mean absolute error, and root mean square error. Both prediction model is developed using MATLAB R 2017A software. Before getting the prediction data, the neuron structure must be determined to get the optimal number to be used for the network. Based on MSE calculation on static neural network architecture, we get the optimal number of neurons is equal to 2. The figure shows the result by using the static neural network. Same goes with the static neural network approach. We must also determine the optimal number of neurons for NNARS architecture. Based from the MSE calculation, we obtain the optimal number of neurons is equal to 5. The figure shows the result from NNARS approach as compared with the real solar radiation value. The table shows the overall performance analysis results based from the prediction values of static and NNARS as compared with the real solar radiation values. The lowest values shows the best prediction measurement values. Based from the results, the graph plotted by NNARS is showing a good prediction pattern as compared with static neural network. Performance analysis carried out using mean square error, mean absolute error, and root mean square error shows that NNARS had given low value as compared with static neural network. As for the conclusion, it is shown that NNARS had given a better solar radiation prediction as compared with static neural network and give us better detection on solar radio bursts. Dynamic neural network represented by NNARS is the best prediction model architecture. With several enhancements, it will give much more better result for solar radio burst detection. With that, I end my presentation. Thank you.